Alright, in 6.1a, we are going to talk about multiplying monomials. The first thing we want to learn is what is a monomial. So first off, a monomial is a number, variable, or a product of a number and one or more variables. When we multiply like bases, so if our base is the same, so say we had x to the 4 times x to the 5. They're like bases because these are both x's. We are going to add their exponents. When raising a power to another power, so if we had x to the second times, x to the second to the third, we raise the power to another power, we are going to multiply their exponents. So that would be 2 times 3, which gives me x to the 6th. And up here we added, so we would get x to the 9th. Okay, so let's look at some examples below. Our first one says simplify each expression. If we have 5 to the 2nd times 5 to the 7th, that means we are going to add their exponents, because they have like bases. Both bases are 5s. So we have 2 plus 7, which gives us 5 to the 9th. Again, for number 2, we are going to add our exponents. We have like bases, both are m, so 10 plus 5 gives me 15. For number 3, we have our constants out front, so we have 10 times 5. I'm going to multiply those numbers together. 10 times 5 gives me 50. And then I'm going to multiply my a's together. I have a to the 2nd times a to the 4th. When I'm multiplying like bases, both of them have a. I'm going to add those two exponents and get 2 plus 4. So that gives me 50, a to the 6th. Okay, another example, number 4. If we have all of our numbers out front, so I'm going to have a 1 out front here, 1 times 2 times a negative 3. I'm going to start with those. 1 times 2 times negative 3 gives me negative 6. Then I'm going to multiply all my m's together. I have m to the 5th times m to the 3rd times m to the 1st, so there's a 1 up there. That gives me m to the 5 plus 3 plus 1. Then I have n to the 4th, n to the 7th, and n to the 2nd. So again, I'm going to add those exponents, 4 plus 7 plus 2. And then finally I have p. I have p to the 1st and 6, so I add all my exponents together. This gives me a final answer of negative 6, m to the 9th, n to the 13th, and p to the 7th. Right, for number 5, now we are raising our power to another power. So remember, our rule for that is we multiply our powers together. So for number 5, I have y to the 3rd times 5. 3 times 5 gives me 15. Y to the 15th is my answer. For number 6, I need to cube each part of my number in here. So I'm going to cube the 6, the a, and the b squared. So 6 to the 3rd times a to the 3rd. So remember, that's really an a to the 1 right there. So that's 1 times 3, or just a to the 3rd. And then we have b to the 2nd to the 3rd. We multiply those powers. B times to the 2nd times 3. So my final answer here, let's see, 6 to the 3rd. Let's see if I can erase that. 6 to the 3rd, I have 6 times 6 is 36, times 6 again gives me 216. Then a to the 1 times 3, that's just 3, a to the third. And b to the 2 times 3, 2 times 3 gives me 6. So this is my simplified answer. Okay, let's look at number 7. Number 7, I'm squaring everything inside those parentheses. So I have my negative 4 squared, c to the third times 2, d to the fifth times 2, and e to the first times 2. Negative 4 squared, I get 16. Then I can multiply all my exponents together. 3 times 2 is 6, 5 times 2 is 10, and e, 1 times 2 is 2. This is my simplified answer. Okay, number 8. When I cube each piece in here, I get negative 2 cubed, x to the first times 3, y to the fourth times 3, and z to the sixth times 3. When I cube a negative number, remember that cube, it's an odd number, so that means I'm going to have a negative answer. 2 times 2 is 4, times 2 again is 8, so I'm going to get a negative 8. Then I get 1 times 3 is 3, 4 times 3 is 12, and 6 times 3 is 18. This is my simplified answer. Okay, for number 9, is it possible to simplify a to the 5th times b to the 7th? Explain your reasoning. So if we look, our bases are not the same in this case. So because our bases are not alike, our answer is no, we cannot simplify because they do not have like bases.